Purpose of fairness. Measures in AI product development. Fairness measures in artificial intelligence, AI, product development ensure the creation of unbiased, equitable, and ethically compliant systems across various industries like healthcare, finance, and hiring. In these industries where AI decisions influence lives, understanding real-time monitoring and implementing fairness measures becomes critically important. When industries implement fairness AI models, they can enhance transparency and user trust, set fairness metrics, and address bias during AI performance improvement. Understanding bias in AI systems. Bias in AI represents erroneous assumptions or systematic errors that unfairly favor specific groups. Biases occur when algorithms favor certain groups over others, often influencing equity, equality, and justice. Historical data, societal and institutional inequities, and choices made during model development can create this bias. Developers must include fairness measures in every step of AI development, especially during algorithm design, data collection, model training, and deployment phases. Types of bias in AI. Data bias. Data bias occurs when the training dataset does not adequately represent the population it aims to model. Prejudice bias. Prejudice bias expresses bias based on faulty societal assumptions that have affected the training data. Economic, social, or historical prejudices may influence the data. Algorithmic bias. Algorithmic bias occurs when a systematic error in the algorithm disadvantages a particular group of people. Understanding fairness. Measures in AI product development. Fairness in AI means ensuring that AI systems make decisions without bias or unjust prejudice against any group or individual. AI requires fairness in training data because it bases its decisions on this information. Fairness measures in AI product development detect and fix unjust discrimination and prejudice. These methods measure and reduce bias in machine learning. These measures create fundamental assurance and trust in AI products by ensuring decision-making relies on skills, qualifications, or relevant facts. They ensure that AI products remain inclusive and not discriminatory based on gender, race, age, or existing societal bias. Defining fairness metrics in AI. Fairness metrics serve as tools that detect, measure, and mitigate bias in AI systems. These tools ensure that AI models treat individuals or groups equitably, regardless of their characteristics. Using these metrics in sectors such as healthcare, finance, and hiring helps industries meet regulatory requirements while alleviating biases. Important fairness metrics. Demographic parity. Demographic parity, also known as statistical parity, ensures that AI systems evaluate model predictions for unbiased outcomes by requiring equal treatment of individuals from different groups. For example, in healthcare, demographic parity would be satisfied if individuals of all genders had equal chances to access health services. Equal opportunity. Equal opportunity metrics allow a model's predictions to ensure individuals or groups in similar circumstances have an equally accurate probability of positive rates. This approach provides equal chances in inclusive decision-making to individuals or groups with equal qualifications. Predictive parity. Predictive parity examines whether, for a given group, the predicted positive outcome has an equivalent precision rate. For example, a healthcare service satisfies predictive parity for gender if the precision rate remains the same for males and females. Individual fairness. Individual fairness advocates for individuals rather than groups. It proposes that individuals with similar circumstances must receive equal chances. For example, in recruitment services, individuals with the same qualifications and experience should have equal chances of getting hired. Fairness metrics in regulated industries. Healthcare fairness. Metrics in AI healthcare applications counteract biases in diagnosis and treatment directives. They ensure that patients receive adequate care without bias based on gender, race, or qualification. Fairness measures also ensure the ethical protection of each patient's personal information. Adhering to HIPAA privacy regulations helps the healthcare industry gain and preserve patient trust. Finance. The finance industry needs fairness metrics for decision-making, especially in lending practices. These measures ensure adherence to regulations provided by acts like FCRA for lending practices, ensuring fairness and equality in loan approvals and credit scoring. Industry algorithms must comply with regulatory standards to prevent discrimination. Recruitment fairness measures play essential roles in recruitment decision-making processes to ensure compliance with legislation. These regulations require fair and equal hiring practices. Fairness metrics help industries ensure their algorithms comply with regulatory standards in hiring individuals without discrimination or bias. Purposes of fairness. Measures in AI product development. Avoiding discrimination and bias, improving societal trust and transparency, ensuring equal treatment and outcomes. Compliance with ethical and legal standards. Strategies for balancing fairness measures. Ensuring fairness and accuracy might prove difficult, as achieving accurate outcomes requires data that might reflect some form of bias. When fixed, this can affect usable data. Pre-processing methods. Pre-processing methods focus on identifying and removing biases from data before model training. They adjust sample weights for equal representation, remove elements contributing to bias, and combine diverse samples for training data. By following these practices, organizations achieve minimum levels of balance and accuracy. In-processing methods. Developers utilize in-processing methods during AI model training to adjust the learning process, input fairness rules into model training, and train AI systems to guard against, detect, and mitigate bias patterns. Post-processing methods. Post-processing methods analyze model outputs to ensure they meet fairness requirements. They adjust predictions and modify decision-making thresholds after training to promote equal outcomes. Future of fairness in AI. The future of fairness in AI will include many improvements due to AI's rapid progression. As AI grows, advanced tools with new features will evolve to detect and mitigate bias. Researchers will find ways to explain AI decisions clearly, and innovations will transform data collection and model deployment methods. As AI improves, developers must integrate ethics into their development to ensure equity, fairness, justice, and inclusivity.